Hello, class. In this lesson, we're going to learn how to simplify and multiply radical expressions. As a warm-up, I'd like you to make a list off the top of your head of all the perfect squares that you know from least to greatest. Here's my list. That includes perfect squares that we get from squaring the integers from 1 through 20. Hopefully you got at least the first row. Those are the ones that we get from our multiplication tables, up to 12 times 12. But you should also know some of the other ones by sight in the second row. So let's talk about some vocabulary here. A radical expression is an expression that has a radical sign in it. Here are two examples. And what do we call the expression that's inside the radical sign? We call that the radicand. Here the radicand is 5. Here the radicand is 8y squared. And finally, the little number that we have over here in the radical sign is called the index. And in the case of a cubed root, it will be 3. And we have square root. We don't usually write the index, but the index is a 2. So keep that in mind. And here's a very important property that's going to help us simplify these expressions. When you take the square root of a product, that's the same as the product of the square roots of the factors. What does that mean? Well, if it's the square root of a times b, that's the same as the square root of a times the square root of b. Now keep in mind that a and b have to both be non-negative. We can't take the square root of a negative number of a negative real number and get a real number. So, right, if you square a negative, you get a positive. If you square a positive, you get a positive. If you square 0, you get 0. So these can't be negative. And let's look at an example of this. So 36, square root of 36, we can rewrite as the square root of 4 times 9. Now if we apply our rule here, it's the same as the square root of 4 times the square root of 9. What's the square root of 36? That's just 6. The square root of 4 is 2, and the square root of 9 is 3. So 6 is 2 times 3, that checks out. So to simplify, we have to follow the rules here. We say that expression is in simplest radical form when the radicand has no factor in it that's a perfect square in this case, because we're only going to deal with the square root. Because we know that the square root and the perfect square will undo each other. So, and also, this is more important in the next lesson. You can't have a radical in the denominator to have it in simplest form. So how do we go through this? Well, the goal is you want to figure out what's the biggest perfect square that's a factor of the radicand. And notice that in my list here, I don't include 1. 1 is always a factor. When we take the square root of 1, we get 1. And with the multiplicative identity, it doesn't change anything, so it's not useful. So we start with 4. Now, to whittle down your search, what you can do is start with half of the radicand. So half of 75 gives us 37.5. So you have to start with a number that's less than or equal to 37.5. If it were bigger than half, then you'd have to be multiplying by some integer between 1 and 2, which is impossible. So this is the biggest possible factor that you could have. And so we start with 36 and go down. And the biggest one is 25. And 75 divided by 25 gives us 3. So 25 times 3 is our pair of factors. And 25, now I'm going to show you this just so you get the basics down, but usually we skip this step. 25 we can rewrite as 5 squared. And now we apply our rule. This is the same as the square root of 5 squared times the square root of 3. And the square root and the square undo each other. And we end up with 5 times radical 3. Let's look at another example together, and then you can practice some on your own. So for 28, what factor would we use here? What perfect square? Well, half of 28 is 14, so we'd start with 9 and check down. 9 isn't a factor, but 4 is. 4 times 7. And notice we usually put the perfect square factor first, because we want to put our, when it simplifies, we want to put those numbers in front of the radical sign. So square root of 4 is 2, 2 square root of 7. So try number 2 on your own. So for 45, you should have gotten square root of 9 times the square root of 5, 3 radical 5. Now try these two on your own, and I'll show you my solutions. Well, 36 is a number on the list. So for 36, you should also always double check that your perfect square is, make sure that's not an element on the list. So if it is, then it's really simple. You just take the square root of it. and it's 6. So that's the only exception for taking half of your number and hunting down. So for 32, hopefully you got 4 times radical 2. Now, I'm sure some of you probably thought, okay, well, I know 4 times 8 is 32. 4 is on my list. While that works, it's going to be more steps, because 8 is 4 times 2, and we can simplify that some more. So while this will work and you'll get the right answer, it's a whole lot simpler if you just start off with square root of 16 times square root of 2. So why don't you try this example using Pythagorean theorem and what we just learned. So the hypotenuse is going to be c, a squared, so it's going to be 5 squared, b squared, 13 squared. So it's 25 plus 169. So c squared is 194. And what's the square root of 194? Does that simplify at all? Well, 194 isn't a perfect square. And 194 divided by 2 gives us 97. So you'd start checking with 81 down, see if any of those are factors. And it turns out none of them are factors. So this is in simplest radical form. Similar idea here, but now you want to figure out the length of this leg. So I called it x. So I'm going to try to solve this example, and then I'll show you my solution. So hypotenuse is 10. That goes in for c. 10 squared is 100. 4 squared is 16. Subtract 16 from both sides. You get 84. What's the biggest perfect square that goes into 84? Turns out that it is 4. You get 4 times 21. Square root of 4 is 2, so 2 times the square root of 21. So now we can also multiply radicals. You follow these steps. You multiply the numbers that are in front of the radical signs together, and leave that product outside. Multiply the radicands together, and leave that inside the radical. Then you simplify if possible. So for example, over here, we're going to multiply 3 times 5, that's 15. And 6 times 2 on the inside, that gives us 12. Now 12 isn't, until we can simplify it. Because we can write 12 as 4 times 3. And the square root of 4 is 2. 15 times 2 is 30. So 30 square root of 3. Example 2, same idea. 4 times 5 is 20. And 2 times 3 is 6. And 6 we can't simplify anymore. So it's just 20 radical 6. So why don't you try examples 3 and 4 on your own, and then I'll show you my solutions. So in example 3, that's the square root of 36. And the square root of 36 is just 6. In example 4, 3 times, there's that 1 out there from the multiplicative identity. 3 times 1 is just 3. So 3 times the square root of 18. And what's the biggest perfect square that goes into 18? That would be 9. And the square root of 9 is 3. So 3 times 3 is 9. 9 radical 2. Square root of 5 times square root of 5. 5 times 5 is 25. Square root of 25 is 5. Determine the area of a square with that side length. So to figure out the area of a square, it's just the length of the side squared. So we're going to square 4 radical 3. And we can rewrite that as 4 radical 3 times 4 radical 3. 4 times 4 is 16. 3 times 3, 9. Square root of 9 is 3. 16 times 3 is 48. Now, maybe you wanted to do that slightly differently. Apply your power of a product rule. Remember back in algebra. If we're squaring this, that's the same as the product of the squares of the factors. So we can square the 4, square the square root of 3. 4 squared is 16. Square root of 3 squared is 3. 16 times 3 is 48. Really a matter of taste how you want to do it. Same answer either way. And finally, figure out the area of the triangle. So what's the formula for the area of a triangle? It's 1/2 the base times the height. Let's see if you can solve this problem. So it really doesn't matter which one you call the base or the height. You can always turn it. It's just a matter of semantics. So 1/2 times the square root of 12 times 2 square root of 2. 1/2 times 2 is just 1. So all we have left is the square root of 24. Biggest perfect square goes into 24 is 4. Square root of 4 is 2, so we have 2 radical 6. In this lesson, we learned how to simplify and multiply radical expressions. Thanks for watching this video.